So, hello everyone, Raghvendra Singh welcomes you all in the another video. So, today we are going to complete unit 3rd, 4th and 5th of discrete mathematics. Discrete mathematics. As I told you, it is similar to data structure in computer science. So, what are the topics in unit 3rd? We are going to discuss a simple permutation and combination, which you know already. And binomial theorem, inclusion exclusion. So permutations versus combination. Permutations are the position, means order or code. Combinations are the choosing. So basically, if someone asks what is permutation, clearly permutation is nothing but positions. Position. Order matter like a pin code. Order matter like a pin code. Pin code. Okay. Combination are for choosing. Combination for choosing. Combination we use for choosing. Order does not matter in this. Order does not matter. Now simple binomial theorem. You all know what is binomial theorem. Binomial theorem. You have studied in 12th class what is binomial theorem. It is the formula of calculating. Suppose we have very big 7 or 10, then we use formula NCR into R into P and into C. So we will know it about later. So now let's discuss some about permutation. So basically permutation, if I want to elaborate it, then I can write permutation, an arrangement in a sequence of element, an arrangement in a sequence of element, in a sequence of element, in a sequence of element of a set is called permutation. Okay. So basically permutation formula is NPR. We denote by P of for permutation, n factorial, n minus r factorial. This is the formula. So let's take one example on it. So basically here will be n in binomial theorem. Why here will be n? Because n is for any number. Here can be anything. So right now this was about permutation example. We can do so many questions on the basis of it. Very simple formula. Now let's move on to the combinations. So basically combination is choosing of a element in a particular set. I'm not writing definition. So formula in this and CR, here C for combination, is equal to n factorial upon n minus r factorial into r factorial. Okay, this is the formula for combination. Now let's do an example. Example number 1. So what is example number 1? We have given that n minus 2 is equal to 10. Then find n. Okay. Yeah, so what can we do is n minus 2. So basically here instead of this combination we will use this formula. So what is formula? N factorial upon n minus r. So this is n, this is r. Here r is this. Okay. So n minus 2, right? Factorial into r factorial. What is r? N minus 2 only. N minus 2 factorial. Okay, is equal to 10 as given. So now we have to open it and we'll get the answer. So for this what we have to do, here is n factorial. I can write it n minus 1, n minus 2. So n into n minus 1 into n minus 2. Why I'm writing this? Because we can see, I can see here is n minus 2. So here I can see I can write n minus n plus 2 factorial, right, into n minus 2 factorial. I hope this is all visible. So this to this will get cancelled, right? Here as you can see n plus n minus n. So I can write by multiplying this, n square minus n upon 2 is equal to 10, right? So I can write it n square minus n minus 20. So after just calculating it, n square minus 5n plus 4n minus 20. So n minus 5 plus 4 n minus 5. Here n is equal to 4, n is equal to 5 and n is equal to minus 4. So minus 4 cannot be taken, so n is equal to 5. Okay, I hope you all have understood what I did. This was very simple question. Now let's move on to the next. So next question is very simple. So example number 2 is 5 people to be formed. How many? 5 people. I'll write in short because there is very lengthy questions. Generally it is a kind of theory. I have to write for whole theory, then a small question we will form. So 5 people to be formed from a group of 4 men and 7 women. We have to find the 5 people group from a 4 men and 7 women. Okay, 4 men, 7 women. How many possible committee can be formed by at least 3 women? At least at least 3 women. At least 3 women are in the committee. Okay, so I have to keep it in mind. At least 3 women should be in committee. So what can I do? There are 5 people, means 3 women means 2 men fixed. Okay, so it is very simple. Total number of in women, 3 women at least. So 7C3, right, into 4 men, out of 2 men will be selected. 4C2, okay, plus 7C4, now men, into 4C1 plus 7C5 into 4C0. So now we have to simply solve it, and how we will solve it, as I have told you, formula, that is n factorial upon n minus r factorial into r factorial. So I'm just I have already calculated it, so I'm just writing directly. So this will be 210 plus 140 plus 21, means this is 371. Okay, yeah. So now inclusion exclusion. So what is inclusion exclusion? So basically a way to count inclusion exclusion is a way to count item in overlapping groups without counting the middle part. A way to count items in overlapping groups, to count items in overlapping groups without counting in overlapping groups without counting the middle part twice, without counting the middle part twice. Okay, yeah. So this was unit number 3rd, and now some topics of unit number 4 is there are some topics of unit number 4. So basically unit number 4 we have some topics. There are, first is generating function. So what a generating function is? A cloth line on which we hang a sequence of numbers to study them using algebra. A simple like cloth line, kind of, let's think of cloth line on which we hang a sequence of numbers, on which we hang a sequence of number on which we hang a sequence of number to study them using algebra. To study them using algebra. Okay. Recurrence relation. Recurrence relation. An equation where the next term depends on the previous ones. An equation where the next terms depends on the previous ones. The previous ones. Like a Fibonacci sequence, okay? Or I can also say a relation which calls itself again and again. I can say this. Now substitution method. Substitution method. This is unit number 4. So what is substitution method? Substitution method is nothing but solving a recurrence by plugging the formula back into itself until you find a pattern. Okay. Solving a recurrence by plugging the formula the formula back into itself. The formula back into itself until you find a pattern. Okay, so now let's take one example. So here question will be something like this: Tn Tn minus 1 plus 1 and T of 0 this. So T of n minus 2, just here this plus 1 and plus 1. Okay, now T of n minus 3 plus 1 and 1 extra plus 1. Okay, so this will be going on. So T n is equal to Tn minus k for kth. Plus k. So this is first equation. Now we have to solve this. So n minus k is equal to 0 means k is equal to n. So we can replace it from putting in this value. Okay, so t of n minus n plus k. So n minus n 0, this whole term will be 0, so t of n is equal to k. Sorry, in place of k we are putting n, so this will be n. Okay, t of n is equal to n. So we have to consider the highest degree. That is 1. Okay, yeah, so it was it. Now characteristics roots are a technique to solve a linear recurrence by turning them into simple quadratic style equation. Okay, now let's move on to the next unit, that is unit number 5. In this unit we are going to study about graph theory. So unit 5, graph theory. So basically in graph theory there are some topics: DFS and BFS, depth first search and binary first search, spanning trees, planar graphs, Euler circuit, Hamiltonian graph and all. So if someone asks what is graph, basically graph is nothing but ordered pair of vertices. So graph is a order of vertices and edges. Okay, so graph is a order of vertices and edges. And what are the vertices and edges? So if I am drawing our nodes, suppose this is 1, this is 2, this is 3, this is 4. So this to this to this to this. So basically these are the nodes and these are the edges. These are the edges weighted. What are the weighted? If I am defining it, it is suppose 8. I am defining the length of this edges. Okay, so not going in the deep, let's move forward. Isomorphism of graph. Isomorphism of graph. So what is isomorphism of graph? It is nothing but if we have some conditions, if graph G1 and G2, have some following condition, then we can say it is the isomorphic graph. First is number of vertices same. First condition is number of vertices same. Second condition is number of edges same. Third condition is degree sequence. And the fourth condition is 1 to 1 vertex. 1 to 1 vertex. Okay, so these are some conditions which we need to remember. Now there are some graphs which are named on the mathematician. First is Eulerian graph. Eulerian graph. So what is Eulerian graph? So every 0 or 2 vertices of odd degree, vertices of odd degree occurs exactly once in a path. Exactly once in a path. Okay. It was Eulerian path. Now same Eulerian. It was Eulerian path. Now Eulerian circuit. Eulerian circuit. So what is Eulerian circuit? First is each vertices should be even. Each vertices should be even. Okay, so I can write this circuit which contain every edge of the graph exactly once, which contain every edge of the graph exactly once. Now Eulerian graph. Okay, so Eulerian graph is a graph which has an Eulerian circuit. A graph which has an Eulerian circuit, CURCICUT. Now let's study about Hamilton graph. Hamilton graph. So basically Hamilton graphs a path that visits every dot once. A path that visits every dot once. What are the chromatic number? So chromatic number, the minimum number of colors needed to color a map so that no two connected regions have the same color. Okay, it's very simple. So basically, let's move to the handshaking lemma. Handshaking lemma. So max degree of any vertex in a simple graph with a vertices is, so max degree of any vertex max degree of any vertex in a simple graph with a vertices with n vertices is n minus 1. So n I is equal to 1 or dv of I 2 of xc. It can be now here planar graph. So it is, if it can be drawn and a plane in such as a way that no is cross one another So formula is v minus e plus r is equal to 2. So structure can be something like this: R1 and R2. This is outer side R3. So this was planar graph. So yeah, now spanning tree is a skeleton of graph that connects every dot using the fewest possible lines. Okay, so you all know this. So thanks for watching.